Hi everybody, today let's learn about how to find the area of a polygon. If we are given a polygon and we have the coordinates for every single vertex of that polygon, we can use this formula to help us to get the area easily. This one we call it as a shoelace formula. So it's actually very useful. We can use this formula not only for finding the area of a triangle or quadrilateral. It can be used to find the area of a polygon which has more than 4 vertices as well. And you have to be more careful. When you use this formula to help you to get the area of a polygon, always remember you have to write 1/2 in front. This 1/2 is not only for triangle. Some students might misunderstand. They thought that this 1/2 is only for triangle. When we find the area of a quadrilateral or a pentagon and so on, we don't need 1/2. This is not correct. If you use this formula, always 1/2. Okay, and if you have 3 vertices, there are 4 pairs. If we have 4 vertices, we have 5 pairs. Okay, the last pair and the first pair always the same. The last pair and the first pair, the last pair and the first pair always the same. This last pair is actually just copy again the first pair. Okay, so you will notice that I draw this arrow using different color, blue color and yellow color. So how do we apply this formula to help us to get the area of a polygon? It's actually very simple. Okay, now we focus on this direction first, blue color one. It means that x1 times y2 plus x2 times y3 plus x3 times y1. Okay, then we complete all the directions for this direction. Now we go another way. Now we focus on red color one. This part all minus x2 times y1 minus x3 times y2 minus x1 times y3. Then you press your calculator, you modulus it, you times 1/2, you get the area. Okay, so normally we prefer to arrange the coordinate for the vertex in the directions of anti-clockwise or counterclockwise, so that here will give us positive. But it's okay if you want to arrange this way, clockwise, no problem, you get negative. But since we have a modular sign, no matter negative or positive, we always change it become positive at the end. And when we come to quadrilateral or pentagon and so on, just be more careful. When you arrange the coordinate for all the vertices, you can either go anti-clockwise or clockwise. You cannot jump like this. Let's say the first pair will write this, second pair, third pair, fourth pair. It's not correct. Okay, you can either go clockwise or anti-clockwise, remember. Now let's see how do we use this formula to help us to solve some questions. Let's look at this example. Given that A, B, C, we have the coordinate for every single point. This is a triangle. We don't have a diagram, but it's okay. Since we know the shoelace formula, we can use that formula to help us to get the area of this triangle easily. So the area of triangle ABC. Remember, this is a triangle, 3 vertices. We have 4 pairs. And if you want to use shoelace formula, no matter this is triangle, quadrilateral, pentagon, and so on, always write 1/2 first. Okay, then followed by a modular sign. So you can start from any point. You can start from here, here, or here. Okay, so remember x on the top, y at the bottom. 2, 1, 2, 1, 8, 4, 8, 4, 5, 6, 5, 6. Don't stop yet. Remember the last pair, you have to copy the first one again. Always make sure that the last pair and the first pair the same. Okay. Now let's go this way first. Copy the modular sign. 2 times 4 plus 8 times 6 plus 5 times 1. Okay, then we go another directions. Minus 8 times 1 minus 5 times 4 minus 2 times 6. Okay. Then this part you just press your calculator. So sometimes you get negative, sometimes you get positive, but not a problem. It depends on how you arrange the coordinate of the vertices. If you get negative, you modulus it, you get positive, right? Now try use our calculator to help us get the answer. Okay, you should be able to get 21 over here. So modulus 21, you still get 21. 21 times 1 over 2, you will get 10.5 units square. Okay, so this is the area of this triangle. Okay, now let's look at example 15. P, Q, R, S are the vertices of a quadrilateral. Find the area of the quadrilateral. We don't have a diagram here, but no problem. Since we have the coordinate for every single vertex, we can get the area easily. So normally we will just follow the sequence here when we arrange the coordinate. Area of quadrilateral PQRS. Remember, every time you use a shoelace formula, start with 1 over 2. Okay, then normally we just follow the sequence here, PQRS. So 4, negative 2, 7, 2, 6, 5, negative 3, 4. And don't forget, this is a quadrilateral, 4 vertices. We should have 5 pair over here. So the last pair, just copy the first pair. Always make sure that the last one and the first one the same. Okay, now we can start to calculate. Go this way first. 4 times 2 plus 7 times 5 plus 6 times 4 plus, when you have a negative, be more careful, negative 3 times negative 2. Okay, now we go another way, minus 7 times negative 2. Okay, always be more careful when you have a negative, minus 6 times 2 minus negative 3 times 5 minus 4 times 4. Okay. So here we just use a calculator to help us get the answers. Okay, you should be able to get 74. So modulus 74 will still the same thing. 74. Okay, 74 times 1 over 2. You will get 37. Okay, so this is the area of this quadrilateral. Now let's look at this example 17. Given that point A, B, C, they are collinear. Collinear means that they fall on the same straight line. If they fall on the same straight line, they actually don't have area, right? If they are not collinear, let's say they are not collinear. Okay, let me draw again. If they are collinear, it's A, B, C. Okay, let's say A, B, C. Here we don't have area, just one straight line. If they are not collinear, like this for example, A, B, C, then we have area, right? This is the area. So from here we know that if they are collinear, if we use the shoelace formula to help us to get the area will be equal to 0, right? So if we understand this concept, we can get the value of t. So for this question, actually we have another way which is easier to help us to get the value of t. So I will show you both. So let's use this shoelace formula first. Since that they are collinear, I know that the area will be equal to 0. Use this formula. Don't forget to start with 1/2. Put modular sign. Okay, now I have -4, 6, t, 10. 3t, 14. Always remember, last pair, copy the first pair. Okay, so okay, -4, 6. Okay, and this whole thing I know must be equal to 0 because they are collinear. They don't have area here. Okay, so 1/2 bring over here means that 0 divided by 1/2, you will still get 0, right? Okay, so let me copy first. Zero divided by 1/2, you get 0. Okay, so now let's go this way first. Plus, plus, plus. Okay. -4 times -4 times 10 plus 14t plus 3t times 6. Okay, then we go another way, minus 60 minus 3t times 10 minus, when you have a negative, be more careful, -4 times 14. Okay, let me check around that. Okay, and this is equal to 0. Okay, so inside here you can start to press the calculator. -4 times 10 minus -4 times 14, and then for the t part. Okay, maybe I show you over here. So this you get -40, and then plus 14t, and then this is 18t minus 6t minus 30t, and then this is -4 times 14 plus 56. Okay, let me check around that. Okay, correct. This and this, we can do it. So -40 plus 56, you will get 16. Okay, so this part you just use a calculator to help you. 14 plus 18 minus 6 minus 30, you will get -4. Let me check around. Not -4t is equal to 0. Okay, since this is equal to 0, if you have modulus x is equal to 3, right? So we know x is equal to 3 or x is equal to -3. If this is equal to 0, we don't have to write x is equal to +0 or x is equal to -0. They are the same thing. So we just change it become x equal to 0, right? Okay, here the same thing. Since this is 0, we only have one answer. Okay, let me write over here. 16 minus 4t is equal to 0. And then I move the -4t over here. 4t. So t is equal to 16 over 4. T is equal to 4. Okay, so write the answer over here. T is equal to 4. So this is a way how we use this formula to help us to get the value of t. But actually, if we use this method, it's more complicated. So now I'm going to show you another method which is easier. if these 3 points are collinear, means that they fall on the same straight line, correct? So last time you learned about the gradient. If they are collinear, they fall on the same straight line. Gradient of AB will be equal to gradient of AC will be equal to the gradient of BC, right? So gradient of AB is equal to gradient of AC. So if you don't want, you can write BC. So AB, focus on these 2 points. 10 minus 6. I hope that you still remember how to find the gradient. 10 minus 6, right? Y2 minus Y1. And then X2 minus X1. T minus negative 4. Okay. Then AC. AC is this and this. 14 minus 6. Remember Y on the top, X at the bottom here. Huh? So 3T minus negative 4. 3T minus negative 4. Okay, this is equal to 4. Here become positive. T. Okay, let me write over here. So 4, this part, T plus 4. And then this is 8. 3T plus 4. Okay, so next we just cross multiplications. Four times 3T plus 4 is equal to 8 times T plus 4. Okay, let me check correct or not. 3T plus 4 times 4. Okay, correct. So this is, do some expansion over here. 4, 3, you get 12. 4, 4, 16. 8T plus, okay. So this is T. Okay, let me write again. This is T. This is plus. Okay. So now we just group the T together. 12T minus 8T. 32 minus 16. So this is equal to 40. And this is equal to 16. Correct? Okay, so T will be equal to 16 divided by 4, which is equal to 4. You see, we get the same answers. So this question, you can use this method or the method I showed you just now. Both will give you the same answers. Okay, for this video, I stop here first. So hopefully you understand better after watching this video. See you next time. Thanks for watching. Bye-bye.